We're live. I don't know why we're live. It is Sunday, but I feel like working on this thing just for a little bit. No, just for a little bit. PufferLib/sweep. Okay. We're going to debug this implementation and see if it does anything. What we will do right now. I'm trying to think what other stuff I actually really have to do today. I think I pretty much just have to check a couple financial things. And that's about it. So I think I'm good to work on this for a little bit. I mean, there's all sorts of other stuff I'd like to do, but this is higher priority. I gotta find some followers that I can just, like, ask shit about, ask shit in various different areas. Because I end up spending a fair bit of time outside of RL trying to do research on other areas. I probably know somebody, come to think of it. Oh. Be good. What is this? No, this is not going to be a generator. This is stupid. In fact, what the hell is this? Why did I make this a yield? I'm gonna have to fix that at some point. Why would I do that ever? I hate generators. Oh, it's fast. Shut up, you're using Python. How to... No adder search center. How about mean? Success. Self.success. Too many C's. Ooh. None. I bet I forgot to return it. Yep. Turn. Why does it try to make it a tuple? Python's so weird. Still no? That is weird. Suggestion index is 1. There should be less than equal. Why, that's jank. Operand could not be broadcast. Does NumPy have... I can just do like this, star none, right? Okay. Sigma. Wait, what? NumPy random, rand int. Yeah, those are mu indices. Well, this is just... Isn't this it? Of 1. So let's do... input dim input. Yeah, this is num input. Okay. Very good. Wait, mu.shape. That's not right. You did it wrong, dummy. Does this work? Looks like it works. Deep copy. Isn't that kind of weird? Yeah, it's different seeds. So how's that happening? Also, why is it so slow? I shouldn't be so slow. Oops. Is the sample function slow? That's not bad. Wait, what? Still takes time. That's bizarre. Huh. So something's broken here. Huh. It looks like they never got normalized. That's what that looks like to me. So actually, the thing that happened, that's so funny. It's just like giant number calculations with the exponents that's that slow. That's weird. See, if I were writing this in C, the computer would probably just blow up or something. Which is the desired outcome. To be punished for writing such garbage. O2 should have a min. You should absolutely have a min. Oh, you know what it is? See, this is why we hate inheritance. And we will probably find a way around having to do any of this garbage. Wait, no, I didn't even define... something weird here. Wait, self.min. Oh. Which came first, the chicken or the egg? I see. Oops. Okay, great. So we're on to this. Key error 0. How's this happen? Yeah, I see. Okay. So all the scores are always the same. But this does run. Params best. And we return params. Carbs.suggest args. Makers. And I don't think that this suggest needs to take in anything, right? Yeah, args is no longer used. Hey, there we go. And all I need is another terminal. Server. Who's using this? Do I have a server up? I don't think I do. Yes, I do somewhere. No idea where. Visualize. Empty chart. Okay, what's wrong with you? Oh, I forgot to just here. Lovely. So this is the result of the randomized neocarb search. I don't know how the heck you get a point sampled this far out, but and which task were we on? Linear? I mean, that's fairly interesting. Num random samples. Give it 200 runs real quick, because we can actually do that now. It's fast. So much faster. Okay, this task isn't supposed to work like this. So, something's probably wrong here. This looks, yeah, there's something wrong for sure. Let's see if this works. Holy. Nope. Ah, okay, we're returning them in the... Okay, so this is in the wrong space. They need to do, okay, here's what we're gonna do. And then scale is already normed. -1 to 1. And then this has to get suggestion. And then fill will unnormalize, right? Yes, fill does unnormalize. Way better. Way, way, way better. It's actually pretty funny how well that does. As just like as a baseline. The 100 points, you can see it doesn't fill it in as nicely. And then if we do 1,000 points, still works like instantly. And this is what you get. So this is, let me just put this into perspective what we have here. We have a version of carbs that runs instantly without any of the overhead, where we've discarded all of the math. And it still does pretty decently. Can we do random for comparison? Is it better to re-implement some already built environment or go full out on something new? It depends on your reference and what you're excited about. So if you see an environment that you think is cool, that you think will add something to Puffer that's not going to be a ton of work, then go for it. It is possible for reference code bases to have negative value. Many of them in academia do. There are many code bases that are so bad that replicating them with good code that's actually usable is harder than just coming up with something that'll be better. I'd say this is somebody who, I guess technically I professionally wade through academic code bases. I can say that. A good example of this is Overcooked. It has that code base boggles the mind. Generally, you should, for a first environment, you should look to do something that's going to be between 200 and 500 lines. A good chunk of that as well will be logging, allocation, free. Then there's like, 150 lines of env code, 200 lines of env code. You can do a fair bit in that. Like, I think Snake is about that length. Our multi-agent Snake implementation, I mean, that we have is about that length. You can do quite a bit with that. Do you have any ideas around that? Like new environments? Let me think. Let me think of stuff we could use at the moment that would be in that simplicity. Oh, so many options. You think? We're going to be looking at curriculum, exploration. Zenf covers that pretty well. See, I'm trying to think of things that aren't out there in directions I haven't explored yet, and where I don't know if I'm giving you something crazy hard. Like last time, I gave Enduro to somebody as a project, somebody fairly new, and he did it, but it was way more complicated than I expected. Let me think of like what is something that I've wanted. There's so many things I've wanted to have in here for a while. It'll be fun, yes, but I don't want to give you something that's too large that'll be discouraging, especially without knowing your level of experience. If you tell me you're a sea whiz, that's another story. But see, multi-agent dynamics are also hard to test. Oh wait, I think I have something. Let me think. Let me think if this is actually a good project. Yeah, I think this is good. What do you think about this? So, this is like, it's a flocking thing, right? Yeah, this is from Artificial Life. It turns out that you can create like these flocking type behaviors with very simple rules. So all you do is if you just put the constraint that, where is it? Yeah, birds try to stay, they don't get too close. They try to match velocity of neighbors, and they try to move towards center of mass. You get these really cool looking sims. So what I was thinking you could do is you could implement this, but then so you could implement this so that you get this type of behavior, so you know your sim is correct, right? But then what you can do is you can replace these rules with rewards and see if we can RL like cool flocking behaviors. I think that this is a really short implementation as well. Yeah, it's a really short implementation. And it'll be funny because we can use the puffer as the we can use the puffer as the character. Is that something you'd be excited about, or should I pick something else? I think that's like a, 100 to 200 lines of logic kind of a thing. You'll pretty much be able to follow the snake logic as a template. You get to have some fun playing around with training as well, because it'll train really fast. Only thing that'll be a little tricky will be the observations. You don't want to do, well, observations will be a little tricky. You can figure it out though, I'm sure. Can you pick one more? Yeah, let me think. So this is one option. Let me think of something else as well. So really I have a couple of really complicated ones in mind that I'm definitely not gonna hand out willy-nilly. Let me see if I can think of something simpler. See, I think of other Atari games as well, just to like round out our collection of arcade tasks, but a lot of them are actually more complicated than you would suspect to implement. Do you have a preference for like continuous, like with physics, like basic physics, or like discrete, or do you have any preference around anything? Or am I just coming up with something here? See, these board games actually end up being a pain in the ass because you have to script a decent opponent to play against. Ideally, we pick something that doesn't require that. It's going to be too complicated. Pretty comfortable with math and physics. Well, that makes one of us. There will be a lot to do on that. I don't want to give you as a first thing, though. Because the thing is, there are RL details that pop in very quickly. No good M's there. Guys, discussing new M's? Yeah, I'm trying to figure out a good new one for a new friend here. I came up with one option. I'm trying to think of others. Because the thing that's difficult at the moment, right, is we're just starting all the science side stuff. So I'm trying to think of like what type of stuff would be relatively easy to implement and would directly support that. And also be relatively fun. Because we've got some synthetic tasks that are just boring. Pretty comfortable with math and physics. Okay, that is good because there's a lot I want to do there. But I don't want to assign you just like a straight port of... Where's like this RL? Not this one. Not this one. Somebody had a really good C environment for this. I think a lot of these are slow. I can do one also. Oh man, so now I am coming up with multiple new M's for people to build. Okay. So usually people are like, oh, I have this thing I want to build. And I say, great, let's make it an RLenv. But yeah, now I'm thinking about how to like round out the collection. Okay, let me think of like other M's that people use. So the obvious one that like we can always use a few more of are the arcade tasks, right? The problem with them is that some of them are a little harder to implement than you would expect, right? Like if I gave you asteroids or something, then you're gonna go, wait a second, but like the asteroids break into many different asteroids, and then I gotta keep track of all these asteroids. And then I'm gonna have to go through, yeah, but you just allocate a big buffer and you keep them contiguous, and like I'm gonna have to go through that spiel, which is suboptimal. And then there's collision checks and all that other stuff. Other common RLMs. There's so many like medium-sized projects that would be good as well. But smaller ones. Smaller ones are usually, unless it's an existing game or project, they're very intentional. Like, my maze environment would probably count as a smaller project because, well, if you ignore the keys and the doors and like some of the fancy features, that took me like 2 days. There's still a fair bit of code in there for somebody new, though. But let me think along those lines because the maze really isn't great for continuous. I'd like something that gives us like a continuous. It has the option for it, but it's not a great test of it. I'd like something that's like a continuous exploration type task. Something where we can really figure that side out. Voids is more like multi-agent. So I guess I'm looking for a single agent continuous task as an option. First one is for Rishab, I believe. I don't know, maybe you can give out something that would just be a fun, just boost fun, learning, and overall intuition. Yeah, but I can do something, I can find something like that that's also going to be like a legitimately useful contribution at the same time. Like a lot of these things, they look like toys, but they're actually really good research environments. Like Snake, for instance, this is like a toy, but this thing is a really stable many agent environment that can be learned very quickly and has non-trivial behavior. Non-trivial behavior. Let me actually go look for comments. Get some stuff. So see, this is too complicated. Stuff like this is awesome, but this is too complicated. Oh, hang on. Wait. I have something. Um, Let me think how hard it is, though. I think if we limit the number of entities, if we don't try to make it hugely scalable, and we limit the number of entities, it's okay. It is adversarial, though. Adversarial M's are hard. It would be a good multi-agent, though, a multi-agent test. Which we need. Directly competitive. Runnable non-trivially with one agent as well for debugging purposes. Okay, I got something. I'm pretty sure you can do this thing. Where's the stupid? Oh yeah, stupid advertisement. I like how I get rogue advertisements. Of course I get rogue advertisements. You already have my money. Stop. So yeah, I think you could do something like this very, very efficiently with not very much code. It's actually probably simpler than my snake code. Don't bother with like these spiky things, just like the basic, there are dots. If you collide with them, you pick them up if you're bigger, otherwise they eat you or whatever. You have a fixed number of players. You have like a max map size or whatever with at most like 100 dots, something like that. This would be another option. Something like this. This would be this is cool because it's configurable multi-agent. It's continuous. You could run it discrete as well. Like you could discretize the action space, so that's a good comparison for us. It should be very simple single agent to get like non-trivial exploration and stuff. What in the hell? It just slowly... Okay, there are people who have been just like on this for hours apparently because this is a planet. Probably set a match size on the lines of snake. Yeah, that's what I figured. So it would be a pretty direct. It'd be pretty direct. It would be a pretty direct port, like a pretty direct comparable. I think that Slither.io or something like Slither.io would be harder because you have to keep track of the snake body in continuous space. But yeah, I think Rashab, if you're interested in doing something like this, I think that the logic for that should be pretty clean. The only things that you have to not worry about too much are like variable numbers of food and opponents. Just don't worry about it. Just allocate for now, just like allocate a max buffer of 128 and then just loop over all of them. And then we'll deal with like if we want really big maps, I'll come up with a way to do that. I mean, I have ways to do that. They're just a little complicated for a first M. That's two options. You want me to come up with some additional, or are either of those interesting? For folks watching as well, I code review all contributed environments live on stream if that is something that you want. So it's a good way to get feedback on RL stuff. No, don't do Slither. Slither.io would be hard, man. Slither.io would be hard. I think Agar would be substantially easier. Because with Slither, like, you have to basically keep track of either a curve or some like line segments or something. I actually don't know off the top of my head how the code works for that, for snakes in continuous space. Agars like like they're blobs, so you don't have to keep track of a growing snake that like can have all sorts of weird angles and stuff in continuous space. You just have to keep track of the size of the blob. Yeah. You can try Slither, but I think it's going to be much harder, and I think it'll be hard to learn good policies on. So I think it'll just be harder overall. Like, much harder. Anshul, what's your background? I can come up with something for you. Or if you have your own ideas, like, this is not just assignment based. We're also very happy when people are like, all right, I got a cool idea. I want to turn this into an RLM. We usually just go, yeah, awesome. More RLMs is good. Oh, dude, that's hard. Are you sure? I'm just telling you, like, that would be. I write some cool code, and I think it would be non-trivial to make that, like, fast and to do this, like, the way that we build our M's. For reference, right, like, I made this thing 1,000,000 steps a second. 2,000,000 closer to, really. Yeah, I did the MOBA, and I still think, I could be wrong. There's probably some stuff online about how they do it, but I don't know if it's easy. I'm a final year student. Yeah, and I'm a PhD who's been writing code since I was 14. Let me think. Let me look. It's also, we don't need two very similar M's. What the hell? Nasty C projects. I at least would want to know the algorithm for this. But the other thing is it's like very duplicate, right? Because we have discrete snake, and then if agar is going to be in continuous space, like it doesn't add a ton, I think. This would still be my, yeah. I mean, so the thing that I was suggesting before was this. Yes, I am a... this also, to be fair, I got stuck writing Python for like 10 years, but I've been writing some pretty cool C stuff lately. Unfortunately, today I'm writing Python, but... Have you seen this? This is Boyd's. It's like this really cool flocking simulation. I think this can be done in like... This is something that would probably take me a day to like get something working. It's going to be probably like 100, 150 lines of real code plus the, the end boilerplate. It has decent ways to test it. It has really cool emergent behaviors, and you can do quite a bit with the sim. And there are tons of blog posts on how to do this stuff. Like, this is the whole logic of it in Python. Oh, or pseudocode or whatever language. Yeah, pseudocode. So probably, I don't know, like a couple hundred lines of C. And there are ways to get fancier with this as well. So if you want to come up with some cooler stuff, right now, it does a centroid, so it scales quadratically with the number of Boyds. Technically, you could do either a quad tree, or if you want to be simpler about it, you just do a fixed grid, and then you allocate a number of entities to each grid cell, and that prevents you from getting quadratic scaling by checking everything on the map. So there's some stuff. Kaggle's Lux S3, I know Stone well. Let me see their end. How did you solve element interactions? Nope, didn't require quadratic or anything. Snake is discrete, so you just have to check neighboring tiles. And I actually do that for continuous M's as well. Let me show you. So without even a quad tree, there's something way simpler you can do. So we have continuous movement right here. You can see I'm moving around continuously, and I'm not stuck to any grid cell, but there is actually a grid on this environment, and the tiles are not tiny either. Like if I use an ability, yeah, so you can see like that is a radius of, I believe, 2 cells out. So all you have to do for collision checks and stuff is you just check everything in those tiles instead of on the whole map. And then, you have a continuous position, but you also have a grid cell position. Environments written in JAX. Let me see what their env is. I tried to tell them that this is... it's like literally harder to write this stuff in JAX than in C. And it doesn't look as cool. Wait, what is the end? Let me see. "2D map and invest." Is the game interesting? It's hard to tell with the current visuals. Oops. This is funny. This is like substantially simpler of an environment than they had in previous years. That's what happens when you use JAX. I feel for him though, because if you're used to writing M's in Python, you go like, wow, I can train so fast. Oh, but wait, it's so hard to write anything interesting. I mean, I also know how much freaking work competitions are, so this is still very, very impressive. Competitions suck to organize. They really do. Let's see if this does something reasonable. Yeah, I wouldn't bother with something like that, though. That's going to be a lot more work. Like, you really can't tell what's going on from the visuals there very well. You're going to want, like, a texture pack or something at the very least, if not animations, for something like that. So yeah, things quickly become more work. I just do Boyd's as a first environment. It'll be a nice contribution. It'll be very quick. It should give you a sense of stuff. There's some interesting optimizations you can do if you want to. I do that. We've got 10 people watching me on a Sunday. Welcome, folks. I do not know why I'm live on a Sunday either. I should probably be chilling out, but all right, so that's some M's. If anyone else is interested, that offer is open, by the way. Agar.io, yeah. You can look, it doesn't have to be a one-to-one reproduction either. It's just like the general idea, right, is, you know, you're a blob or you're a sphere, you go eat other spheres, right? Yeah, that sort of thing. Yeah, and for folks interested, just because we do have quite a few people watching at the moment, PufferLib is an ultra-high performance reinforcement learning library. This is what I'm building full-time now. We build really high perf M's in C, like million steps per second, 1,000 times faster than most of what is in academia. All of these are playable online at puffer.ai. From very simple to like actually pretty full MMO and a bunch of other stuff as well. And most of these are written by contributors, some of whom came in with no RL experience. Pretty much, if you're interested in getting involved, this is a great way to do so. I review all contributed M's on stream. And, you know, once you contribute a couple M's, you kind of get the hang of some of the RL basics, and I start onboarding people onto the cool science stuff that we're doing as well. This project is really my effort to make the field of reinforcement learning sane, consistent, and fast. Actually, we have contributors working on both of these at the moment. I just came up with some prototypes for these, so like Tank Battle N, Trading Card Game. There are several others as well that aren't here yet. All right. So with that, I think we go back to what I was working on at the moment. I'll keep answering questions, of course. But I was working on this hyperparameter sweep algorithm. And, yeah, star the repo as well. Please star the repo. It really helps when people star the repository. Doesn't cost you anything. But, I mean, pretty much the growth metrics I track are stars here and then followers on X. That's what I track. That's generally been pretty good. Okay, so there we go. So this is what we got out of our new version. This is random. So you can see we've already done, well, the random, it's not like true uniform random, it's random around the start points. But you can see already that this is much better. Very good. Hey, the puffer eats stars. That's what he eats. Close some tabs. This is actually kind of funny. Let me explain the significance of this result real quick. So, the paper that this is based off of is Carbs. It's this paper from Imbue AI, they're a cool startup. They used to do RL, now they do language models, like everyone else. But they came up with this really mathy paper. But the key thing was that there's this benchmark called ProcGen, right, which is an arcade benchmark for reinforcement learning, similar to Atari, it just runs faster. And they were able to solve it with PPO and just hyperparameter tuning. So they were able to solve this existing benchmark with the simplest possible method purely by hyperparameter tuning with this algorithm. The algorithm has a bunch of math in it, though. It's very mathy. And when you actually dig into the math, not all of it's exactly well motivated. So I've been working on a new algorithm based on this to see if I can really outperform this algorithm. And there were a few issues. One of the main ones is just the typical academic issue of the code base being kind of a mess. They had way too much code for what this thing is. So just this morning, I said, oh, okay, I'm going to go just make my own implementation of it. And I started doing that and I said, hey, wait a second. There's a baseline version of this that you can do with none of this math. Let me explain how this works at a high level without the math. So I have to briefly explain the concept of Pareto optimality. So let's say that you have two variables, one of which is a cost, which is, say, the amount of time it takes you to run an experiment in seconds. And then you have a score, which is how well you do on your environment. So you're playing Breakout, it takes you 2 minutes, that's your cost. You score 500 points, that's your score. Pretty intuitive, right? So a point is said to be Pareto optimal if there's no point that is both higher score and lower cost. So you cannot give me an experiment, or at least so far, none of your experiments do both better on Breakout and also have a lower cost. The experiment runs faster. It doesn't exist. So what this algorithm is about trying to discover the whole Pareto front, find all the points that are like this. So basically, for however much compute you want to invest in your experiment, you want to get the optimal results. And that is useful because it tells you the shape of that curve. Sometimes it'll be really steep. So you'll say, hey, if you invest 2 minutes, you can basically get optimal performance. You don't really get that much benefit by going more. Or some environments, it's like, hey, this environment scales really well with compute. You just have to keep dumping more compute in and you'll keep getting better results. Things like this. It's useful for other reasons, but that's one of the big ones. So what they do is they generate a whole bunch of points around whatever existing Pareto points they have, and then they score them. So basically, they take this set of Pareto points and they do like this genetic algorithm type thing where they're just like searching around the existing good points that they have. And then all this math, all that this math is for is when you take a bunch of random samples around the points, the math tells you which one to pick. So the baseline I came up with is, hey, what if we just take all the math away and just pick randomly? We just randomly sample what point we're going to use. It turns out that already does pretty well. It does at least way better than the base random search. And this random search is also usually much better than most random search implementations out there. Now, it's not a great baseline, but hey, already pretty good. The best possible performance would be if all the points were on this line and you didn't have any points over here. But again, this is, just moderately better random search. So the next thing is going to be to try to implement my versions of the math to see if we can do even better than this. And this is where it gets a little bit tricky because there are two components to this. There's the math itself, which are these formulas, which I've spent a lot of time looking at and redesigning. And then there are these Gaussian processes. These are a set of learned models. They are learned online as you run experiments. So the results of the experiments, that's your data, and you just train this model as you run more experiments. The problem is very often these models are very bad. So all the math kind of goes out the window when you're using a bad model. So we're going to look at all of this. But that is the quick summary of what we are doing today. Now let's actually do it for a little bit. We're going to need to pull in the model and some of the formulas. Okay. So this is what they have as their model. There's a lot of code here. I think we're just going to copy it and then start deleting stuff. I think that's what we're going to do. I'm just deleting stuff that I know I'm not going to use. In fact, this isn't going to be a separate class. I don't see any reason for it to be. Quantile transformer. This is an input variable. Yeah. Let's see what they call this with. Surrogate model params. And then they call this with params. That's kind of gross. Outstanding suggestion estimator. Thompson, which literally just says Thompson. Okay, so that's all useless. It's really weird how they have to recreate the model every time. Such a mess. So this is Pyro. I've heard about this thing for many years, but never used it. It's very weird that you create a model with the existing parameters like this. I guess because it's analytic. It looks like you do have to recreate it every time based on their API. I'm not about to re-implement Pyro, at least not yet. So I guess we will leave this kernel here, but we will I guess this is going to have to go into down here somewhere. Ah, and here's where they fit. Here's where they fit this. Oof. All right, and this is it. That below this is my code. Let's just start cutting where we can. I know I'm not using this thing. And just replace this with a dict. I know I'm going to have some sort of fit for the Gaussian process. P X Y kernel this goes here actually. So yeah, you'll see me deleting typing information very often from Python. Do not like types in Python because they're not actually enforced. We're going to actually give you a kernel this time. This is, you don't need this on GPU. It's actually slower on GPU. I tested it. That will probably be true for everything that we are doing. So this is now a one-liner with a reasonable line length. And then noise. Tells train. I'll eval. There we go. Now we can get rid of that. Move these up for now. As basic as what I'm doing right now is, this has literally been the best tool in my arsenal for like making RL work. It's just taking like academic code bases with good ideas and cleaning them up substantially until like all the bugs and errors fall out. Bit target transformers. All right, so since this is called there, then this goes here, and then we delete this. I'm looking for like code that looks like it does something in the rest of this. Most of this doesn't look like it does something. Clamp. The variance computation does something. Wait, what? Self? Target variance. Ah, okay. So this is, I was using this at some point. So apparently that's not even correct. Good to know. Let me take a crack at just integrating this now into, because I think that this whole block, right, this is what we care about. And this goes right here. Because it's basically a ranker on the suggestions. Let me see, raw outputs. Ah, I see. So we have to retrain, fit and retrain the model, which is very obnoxious. So maybe, hold on. We'll figure this out. Quantile dot fit cost transformer dot fit. Okay, I want to see the original here. I'm just going to pull it up on the side. I want to see how they were doing this originally. Because the logic here is just very convoluted for what it is. Get model. So this is them training a model. Okay, here it is. Input in basic. And then we have output in surrogate. And then the cost one is log costed. Target to surrogate. Output transformer. Call this first. Okay, so I see the logic here. And this is all just for the fit. So all I have to do is essentially just take, is it surrogate to target? Target to surrogate. So most of these functions just get all compressed as best I can here. There's a bunch of junk. It's very hard to understand. So, okay, here, this here, this is, nope. This is fit target transformers, this block here. And then this block here is fit observations. And we shouldn't need any of this data until down here. So this is going to be we'll also probably like put all this in one separate function at least, because all this is in this big else block. Success observations. Square root using more distance information. Okay. Output transformer. So they want this to be raw outputs. They're doing something very weird here that I have to actually understand with these transforms, because this doesn't seem like it makes sense the way it's written, and maybe it doesn't. So let me go back to this. Oh, also let me reply to thing and put it on my calendar. 4 p.m. Holy, looks like we got some new people in here. Will Doc mess up? I don't actually see what he's talking about. That kind of interrupted my train of thought. Right, I was trying to figure out how they're dealing with the data here. Okay, so they do target to surrogate. What's target to surrogate? Goes from target function space of the score function is a well-behaved Gaussian space. Okay. Output transformer dot transform. Hold on. Output transformer dot transform. I see. So these things are all just done in a weird order, essentially. These are useful, they're just done in a weird order. With a bunch of extra stuff. So let's fix that. Oh, let me fix this first. What? So somebody got linked the 1.0 docs off of Google. Thank you, Google. It's kind of funny. I'll put this over here. So this is success observations. This is raw scores. Okay. Here's our output transformer. Dot fit. Cost transformer. Transformer fit. See if we need these. But there's still some weird stuff going on here. As you fit this, target to surrogate. Okay, then we need this function. We need this. So transform. Okay, it's actually transformed on the raw. What the hell? And this is so convoluted. It's like you make all these damn functions, and then you end up going in circles. Like, because you can't think anymore. Because, okay, they do fit target, right? And then they call this raw outputs. But then they do the same loop right here. So they do target to surrogate on raw outputs. And then target to surrogate does this transform. And then, wait, they fit the transform. Can somebody please explain to me why the heck there is a thing here where you fit a model to some train data and then you use the same model on the train data? Is there not just a function version of this? Where the heck does this come from? sklearn pre-processing? What is this function? Freaking sklearn. Quantile transform. Holy. What on earth? Jeez. What does a quantile what does this even do? Where's the actual logic? There's a NumPy wrapper. Nan percentile. Computes quantiles are monotonically increasing. This get fixed. Okay, so this was never fixed. Wait. Question mark. Is this function literally just in NumPy? What I'm trying to do now is not use scikit-learn. Look at this code. Do you want to use this code? Do you want this code in your code base? No. This is a multi-thousand line NumPy wrapper for functions that literally exist in NumPy that makes it like Java. And there's a second one as well, right? Min-max scalar. That's easy to replace, I'm sure. So I guess the easiest way to do this is going to be, do I have this? Yes. I hope Pyro doesn't look like this as well. It'd be so funny if I end up making an implementation half the length of the original that doesn't have the dependencies. That's how it happens, though. People just wrap stuff, and then everything ends up 10 layers deep. Oops. Forget I'm not in PDB. No attribute references underscore. Okay. Ah. Check inputs. Damn it, I actually have to read a substantial portion of this garbage. Check inputs, validate data, copy, form. Was this the actual function? No, this is... Oh, that's so gross. They did it backwards. They made their function, like their procedural API, a wrapper over their object API. God. Okay. That's crazy. The funny thing is that this is probably like well-tested code as well. It's just written like very big tech. It's like very big tech where it's like you're not ever intended to read this because look what happens when you have to read it. Okay, so n quantiles. Yeah, so they just make it. It's literally just a linspace. And what's this endpoint? And then they call this, so X references okay, so this is the same signature, this is the same thing. AQ, so it's X references, X is just your data. Sample. You don't need to subsample, I don't think. Times 100. That's the same as 0 to 100. And then this is just NumPy NumPy quantile. So we just do dot. That's the same thing. And then let's see, this is their quantiles. And then what do? Return self. Okay. And then what do with this? They call transform. Transform call. So they do this in a loop for some reason. Why do they have to do all this? I think they do all this because this is like interpolation. This is like if you fit on some data and transform other data. But we're literally fitting on the same data. Right? Hello? Yeah, every single time you fit, you make a new one of these. Okay. And then what's this min-max scalar? Scaling each feature to a given range. No. They use this dependency? With all this frickin' code? To avoid doing this? I will never understand big textile code. I swear. I will never understand. And at this point, I no longer want to. Now, the one thing is I think that you do have to multiply this. Yeah, you do have to multiply this by... You do have to do this. And I think I want to do it the other way. So let's not forget that. That'd be bad. I mean, you see how insane this is, though, right? Like, as I just go through here and I just, like, keep pulling the thread, you see how insane this is, right? You add a very heavy dependency that's doing some weird transform, and then you go look at it, and it's, like, 2 lines of code that's included with NumPy. And you go try to read the code, and it takes a while to even figure that out, because it's like some Fang engineer has like onion wrapped and onion wrapped and onion wrapped this thing to make sure it's like fully abstracted, so it'll be very, very safe from anybody trying to understand it. Christ, my gosh. Like, honestly, if that's how I had to write code, I've done some pretty bad stuff with class messing, like object-oriented mess, but like if I had to write code like that, I don't think I would have lasted as a like a software engineer. I think I would have just gotten bored and gone and done something else. To be fair, a lot of like the first many years of learning stuff was like really boring because it would go too slow, because like this is how you're taught to write code. Like, you don't have to write code that way. God. Of course, I say this and then it's going to be real stupid if I mess it up. Log cost. So it's got to be in log cost. And I generally prefer to do this. And this is not self. This is cost. There we go. So there's normalized log cost. And what did they call this thing? Min-max scale. Okay, we're starting to get to a reasonable amount of code. Oh shoot, do I have to apply the same quantile transform to the surrogates as well? Maybe there was something. Hang on. Maybe I did something stupid. Let me look. I don't think so, but output transformer. So then we do outputs in surrogate. We do target to surrogate. So we fit this. We fit this on outputs. No, wait, and then we do target to surrogate, outputs. Okay. You just removed a 600. Yeah. I don't know. I've done some stuff, man. I've seen some shit. Generally, I suggest, like, here's the thing. You can save yourself a lot of time just by, as a general rule, you don't use sklearn, you don't use skimage, you don't use any of the sk libraries. Maybe once in a while you use scipy if you're doing stat stuff. All right? But for the most part, you don't touch these libraries. Like, you can save yourself a lot of time just by knowing what libraries, like, you generally don't want to invest time in learning. OpenCV is another one. If you're not doing very specific CV stuff that needs it, don't touch OpenCV. I almost don't want to look at the source code for NumPy for fear that, like, the illusion of what I hold up is one of the best ever made packages, the implementation is not going to hold up. It's probably pretty good, but I have no idea. I mean, it's probably littered with so many tests and things so that they, because it's like so heavily relied upon. Serve surrogate. Stuff on Discord I'm missing. Is there new stuff on support? I don't see anything. I mean, the reason I'm doing all of this, right, is because I want to get something that's very simple, where I can actually inspect each component easily for errors. And, like, try each component to see if it actually matters. Okay, so when you do fit observations, right? Where's the other one of these? I only see one. I guess this is what you call, do you call fit observations from... Yeah, so every time you call fit observations and then suggestions and then failures. So you're literally refitting these models every single time. Uh-oh, are they using the same model? Hold on. This could be bad. Fit observations before suggestions. Inputs in basic, okay. And then output model.iter sample. Self.out, okay, but this output model, this is the Gaussian process, so we're still okay. And then they concat, and then they call get model. Wait, they call output model.x. The hell? And then they call get model. Dot iter sample. Oh wait, because then they make the output model with... This is insane. This is truly deranged. Truly, truly deranged. I'm gonna be right back. Use the restroom and grab a drink. Be back in a couple minutes. We'll keep on this. This is nuts. Okay. Let's see if I can figure this thing out. Self-output model. We're gonna need the double for this. Okay, so they call get followed by fit, right? Get surrogate model. Wait, no, they call self get surrogate. Get surrogate model. Okay. So what this does is this instantiates this whole class. I didn't miss anything here, right? No, this is all it is. This doesn't do anything else. Good, okay. And then they call fit observations. This is where you create the model. Wait, what? Okay, they make two different models, fine. And then they call fit observations. Wait, fit? No, hold on. They call fit observations. Okay, fine. This is what creates the models, and they use the data for this. So they use the data on the fit, which of course they do, fine. And then they fit the suggestions. And how do they fit the suggestions? Output model. Where's output model? Get defined. Output model, okay. Oh, okay, here. So they fit this. Wait, real number input. Okay, yeah, but this is inputs and basic. So fine, there's no transform on this. They just use the raw, they use the already existing transform space. Fine. And then they call get model. Okay, this makes sense. And then I don't know what the sampler is. Output predictions. Iter sample. Iter? Nuts. It's okay. Iter. Forward. Set data. Are you kidding me? You don't have to remake the model every time. There is a set data. Stupid. Yeah. Iter sample. Iteratively constructs a sample from the Gaussian process posterior. What? Samples lazily. later query points can depend upon earlier ones. Querying is to be done by an optimization routine. Which it is. Samples from Christ almighty. Wait a second. Made. This code's breaking my freaking head. This is output model, okay? Self.output model equal. This is a new model. What? Okay, so at least you're not passing the sampler, you're just using the sampler here. Why are you doing this? We rate the real, both Mean and Thompson, the output model is used to estimate the outputs of the suggestions. This is necessary to do as we await the real outputs. Wait. Fit suggestions. Find inputs. Oh, outstanding suggestions. Wait, what? This is the most confused I've been on one of these. So they fit the past data, right? And then these are data points for which they don't have any labels because you're waiting to score them. And they're retraining the model on the suggestions that don't have labels. Where do you even get outstanding suggestions? Hold on. Remember suggestion. Number of outstanding. What in the hell? Outstanding. Isn't this whole thing redundant? Dot values. I don't know why they're storing these separately, but this doesn't make any sense because they just fit the model to the success observations. This is what you want, right? And then what they do from there, no target outputs are passed in, and they have to be estimated using the surrogate. They're training a model on the outputs of the same model. So they have a model that they just fit with this, okay? And then they have some data that they don't have labeled with it. So they use this model to fit that data, and then they train a new model on both. That's insane, right? I love how my main use case for freaking language models is checking whether I'm insane or the other researcher's insane. Yes. Reducing the incentive to sample near them again? Well, that's not true. I think this is wrong. I don't even see where there would be outstanding suggestion. Yeah, that assumes you have a good model, and these models suck as well. We're ripping this thing out. This is insane. So we don't need to do either of these. Jeez. Yeah, this makes no sense in this context at all. Observations. Where's the original? Output model right here. So fit target, yeah, and then this is fit observations. So all I have to do, these lines, I don't know why people break up code that way. These lines go here. These lines go here. Now, success observations. Wait for X in success. Oh, it's just input in my case. Then they do target to surrogate. Which is this. Literally this. Normalized force. Then get model will be different as well. And what about the cost model? Cost to log cost. This is just log, right? torch.log. Wait, hold on. Cost to log cost. They do log and then they transform. So yeah, I did this correctly. So this is just normalized log costs. And then inputs in basic is just params. That can go here. This is params. Crazy, man. Crazy. I actually want to now get rid of all of this because we don't need most of this, and it's just cluttering my field of view here. Okay. These can go at the bottom. Here we do need torch. Oops. Do these kernels have params? Well, we only have 2 models to make. Or do we have 3? Oh, we only have 2 and they use the same kernel. Hang on. Okay. Let's just put this up top. We'll move this if we need to. Getting rid of this and this for sure. Do you have to create it with data? Is that API just really awkward? You do, that's so silly. Okay. That looks better. So now you create GP. You need to pass it the dim and scale length, which I don't even have for now. Params real dims. This is self.num params. That's all this is. GP opt, then GP cost opt, and GP, oops, cost opt. Very good. Let's here a second. And now we get to do GP, or was it self dot data. Okay. And they train it here as well. So we'll do dot. There's no dot fit, is there? Dot fit. This doesn't have that. Stupid. GP util. And we do the same thing here. Okay, set data, train. Set data, train, eval. Observe surrogate. So self.output model. And the output space of that is already quantile transformed. Actually, this might be a decent transform to use because this is kind of what I was looking for in the first place. Yeah. Would be good to be able to undo the transform. We'll handle that. But first, we do normalize score est GP score suggestions cost estimate and now do I even have to technically undo these? I do have to undo the cost one because I don't want to have cost on a log scale. Log cost to cost. They're just going to use the stupid model, right? Yeah. Cost est. Let's just undo the operation, right? Normalize log cost equals normalized log cost minus divided by STD. Wait, where's it? Hold on, this is now you want to recover log cost STD. So it's divided by max minus min. STD. And then there we go. And then we do cost est. There we go. Undo the transform. Now I think I gotta look at my own code. This is some heavy duty work. Digging through this code. I did not expect this today. 2. Our Pareto observations will be in basic space, so this won't be an issue. And that'll give us a better estimate as well. You don't need this either. It's going to get way simpler. So R divided by cost estimate max cost. There's no, actually, you don't even need any of this. Perfect. And then we do I forgot about y nearest. I will have to do y nearest as well. I may as well do it now. Pareto costs. I think we'll do that after, because there's going to be some more stuff there. Just want to get the basic version of it. You need to apply the clipping above here. So hold on. Okay, we'll clip here. And then these ones are already fine. This one has to be clipped. That's the basic algorithm, I think. Answer normal. Oof. So we'll clean this a little bit up, but I mean, even if I have to add a little bit back, this is replacing like 1,000 lines of code, this little snippet here. So I think that's pretty good. I guess we just try to make it work now. It's 4:45. I'm going to take a second. My brain hurts from that. Jeez. That was a lot of logic to unwrap. So we'll have to debug this a little bit, I'm sure. Once I get this working, we will have a dramatically simplified version of carbs. Not simplified algorithm, it's our version. I think we add like an extra 5 or 10 lines for the one term I didn't compute yet. But this is 259 up to... Yeah, it's like 30 lines of code instead of... there was at least like 500 or 600 lines devoted to this, with an additional 600 lines of useless dependencies. This min-max scale thing is interesting, actually. I'm kind of interested to see, we might want to use that for our parameter spaces, actually. Okay. So we're just going to speed debug this. Search centers. What the heck is this? Duplicated. $13. Yes. Better direction sign. Quantiles must be 0 to 1. Okay. So apparently GP score. No attribute GP. Ah. Int is not callable. Uh-oh. Well, this didn't do what I wanted. Let me say. Accumulate. Let me go look at the reference for this. I guess it's a me special that I had to re-implement this, but like, come on, this code is so bad. NumPy maximum accumulate. This is already done here for us, I think. Dense fit. You have to apply this, I see. Interpolate in one. Let me just, I want to make sure I'm not misunderstanding. This was in their paper, I believe. Okay, so parameter-free method, quantile transform. So what I'm going to do here, in order to figure this mess out, I'm going to do this. Target to surrogate. Okay. This is your X. I can see that this looks to be raw cost. This looks to be raw cost to me. Yep, raw cost. And okay, so this is binning. I think this is binning. Yeah, you can see it is binning. This is screwed up though, because look, 5? I guess it just gets mapped to. It doesn't just get mapped to a standard normal though. It's very weird. Box. Man. Forward transform match the output distribution. Transform data so it more closely follows a normal distribution. When it clearly doesn't. Does that make any sense? Wait, no, this is score. Okay, no, this is valid. This is score. Well, score still shouldn't follow a normal distribution. Confusing math coupled with confusing code. Actually, shifted to follow a normal. Okay. Why do you have to interpolate? Inv. Yes. Empirical cumulative probability. For any new data point, you want to know its empirical cumulative probability, the proportion of data below x. You can use NumPy interp to determine this probability. Map the cumulative probability inverse okay. So that's actually not that bad. Interesting. I think this is still worth doing though, because this is 4 lines of code compared to the 600 from the frickin' dependency. Who knows what that's doing. Wait, length of quantile. That's just Q. So you have your quantiles. This is just quantiles. Confusing stuff. And clip. Let's see about this. This broke my terminal. Does NumPy not have, if I swear, if GPD hallucinated this whole function. SciPy. Well, whatever. Noxious. Okay, this is correct, right? We got 50 points. And then here are normalized scores. Why the hell are some of these infinity? That's dumb. We'll fix that in clipping. That's where this stuff has been stable for years. It's straight up hallucinating. That function did not exist and never existed. Okay, that's better. Oh, it just needs to be obviously, yeah. Try that. On Claude, I wonder what it gives. I mean, it's a whole long conversation. I use both of them, you know, because Claude has the PDF. You can drop in PDFs. You can't drop in PDFs on the new OpenAI models. And then right here, we get the same thing. So we get params. Nope. Not yet. Mm-hmm. LMs don't really read the inputs. You know what we call that, right? Kind of freaking useless. Injects the files into the context. I mean, it seems like it at least kind of reads some stuff. Like, it'll reference formulas and things. It definitely doesn't read it closely, but, Where is this? That's weird. Where did this come from again? Suggestions. Look at that. It runs. Looks like it's a bit faster than before. I'll be amazed if it's any good on the first try, but yeah, there it goes, predicting 200 cost. Let me actually just commit this real quick. $350 lines in the whole file. So I don't know if the samples are any good, but the predictive model is actually correct now. For the most part here. The score and the cost should be equal if your params are optimal. No idea how many points I ran this with. Might take forever. I think in the meantime here. I do want to see my will there be performance loss when running all environments sequentially compared to using PufferLib multiprocessing? They can't be. Will there be performance loss when running? My environments share large read-only lookup tables, so they can't be cloned naively. So most of our experiments, we use, like most of our new environments only use one core because the environments are just so fast that we can run 4,000 copies and we can step 4,000 environments and the model won't even notice. It takes virtually no time. If your environment is slow, then yes, it will be slower. So what you can do potentially, and we do this as well for things that have to share a large amount of data. Can you make like each process have a large group of those environments? So one thing you can do, right, is like each core can have 1,000 copies of the environment, and you have 8 cores, and then on any given step you use 4 cores worth of data. That gives you 2x asynchronicity. It gives you multiprocessing, and that can work very well. Also, we do have examples on using shared assets for C environments. Same thing would work for Python environments, but if you're running for loops in Python, things are probably slow. Rito scores. Which environment? MOBA pathfinding works. That wasn't scrapped as far as I know, was it? Oh yeah, I guess it was. Here, the current thing, I just have, I mean, I literally do this in my latest thing. If you just check, I'll link it to you. Okay, so this is my new procedural maze environment, and it's got a shared level buffer, and we sample from a shared level buffer, right here. This is the current branch I'm working on. I mean, you can see though, it's not particularly complicated. Technically, all of the environments have shared data because of the log buffer, right? It's the same exact idea. Like, we pass the same log buffer into all of the different environments, right? So they all do. That's how we do logs cleanly. Hello, how's it going? I just realized I forgot to reply to my buddy. Yep. Burrito points. Okay, now we got our Pareto scores. EPCX, so cost minus squeeze 1, normalize I want normalized Pareto costs. So this is cost mean. This is actually unnormalized, so this is Pareto cost mean. Y nearest. No, I need Pareto scores. Stiff. Alright, we'll see how that goes. Is this thing still running? Nope, we got it. Neo carbs. Neo V2. Holy hell! What? Hey guys, oh, I think we're gonna solve. I think we're gonna solve hyperparameter sweeps within the next couple weeks here. Are you kidding me? The blue points are random samples, alright? And then the red ones are from later on. So it just beelines along the optimal. Yeah, okay. Jesus. This is without the math. This is with the math. Now, it's not traveling fast enough. We will get to that. But, like, what the hell? That's insane. That's actually insane. Well, I'm glad I got up and did this today instead of lazing around. I have ample time for that in the evening. Okay, this seems to work. Hey. I don't know if what I'm doing makes any sense yet. Hold on. We're going to read through this code while this runs, assuming that this runs. Yep. Okay. Let me make sure that I actually did something that makes some sense here. So these come from the successes. No, this is wrong. Yeah, because here, wait, normalized score mean. This should just be normalized scores. Yeah, let's correct this. Thing I did didn't make any sense. Variable names to clean up and all sorts of things, yes, but we shall see. So these are too conservative, I can tell. I wonder why they're too conservative. Yeah, so this has, it looks like this has had the opposite effect. This is so crazy. What's going on in DMs? Look at this. It's our base one. Needs to go faster, not slower. I think why this could be the case. Normalized nearest Pareto score. Do I have these in the same space? I think so. Oh, hold on. Yeah, so this term is wrong is all. So yeah, it's gonna mess it up because this term is wrong. Right? Be costs. Like this. And then what's our current look like? Yeah, okay, garbage. This is, where is it? Cost mean. So the score prediction is in norm space, so we don't know how accurate it is. But judging by the cost prediction, it should be very accurate. Now this is still driving us down towards the bottom for some reason. I'll have to figure that out. Why would this drive it down? We'll wait for the cost to like kind of match before we look at it. We'll do one more. Okay, lucky. Okay, so it takes like 10, 15 samples to match up. It's not bad. Use the restroom real quick. I'll be right back. Okay. Man. It's one crazy algorithm. Okay, good. Mean. Normalize nearest. I don't think that should be possible, right? Let me see if I have a math error. Normalized nearest Pareto score. It's going to be cost normalized Oh no, that is possible, right? Hi, new to ML, welcome. This is currently attempting to design a really, really good hyperparameter optimization algorithm. And wading through tons and tons of code and math in order to do so. What's going on? This is a complete deconstruction of the carbs hyperparameter optimization algorithm for reinforcement learning. Complete rewrite of the code that was open sourced for this, and a whole bunch of mathematical optimizations on the original, followed by a ton of synthetic testing and a bunch of testing on real RL environments. The goal here is that we just end up with a really, really good hyperparameter tuner for reinforcement learning. I think that's kind of the highest leverage thing in RL right now. If we do this, it will make all the research that I do much easier. I gotta run to dinner in a few as well. I've sort of been on here for the past, I don't know, I was on this morning. I've been on like the last 3-4 hours, I think. But I'd like to at least have some idea of what's going on here. Why is this particular modification not working? Sure. So my theory here, the way that this works is it looks for the nearest lower cost Pareto optimal point. And then it takes the difference between the estimated score of this proposed candidate point and the known score of that nearest Pareto point. In other words, that's a whole bunch of fancy jargon. To mean something very simple. So if you have this, you have some points. And you pick a sample. Let's say that you're going to choose a sample point that's right here. Then it just looks at this distance. So this point to the left, it looks at this distance to see how good this one is. So the idea is once you fill these in, right? So once you fill in the best set of points you can, then there's not really any way to put a new point that's going to like give you a substantial increment. So then what you have to do is you go over here, you know, and you try this. So it pushes you to explore more. That's what this is trying to do, but it's for some reason it's doing the opposite. I don't think I just flipped a negative sign. Hardy, hardy, har. See, this is obnoxious because this looks better. What if I remove the cost mean term? Oh, wait, hold on. Well, I can see already that it is doing it. Oh, you know what it might be? Let me see if this works first. If this works, I think it's the quantile transform. Doesn't seem to be working, though. I wonder if it's the clipping. Hang on, normalized score mean normalized nearest Pareto score. Normalized score mean comes out of this. Oh. Don't need to wonder any longer. Just took a second to figure it out. How many samples was that? 20-ish? It's crazy that it can jump that much. I guess the model just had to get good enough. And then it went and selected one of the other random samples. Now, the thing is that this should fill in the front. It shouldn't just chill out at 200. So if it's just going to chill out at 200, then that's not good either. Push the latest version. Getting hungry here. Oh, wait, is it? Okay, there is a glitch here. Is there? No, there shouldn't be a glitch anymore, actually, because it's filled in now. It might be the quantile transform. We'll have to check that. I'm happy with the progress here, though. There's a lot of good progress today. Is the nearby score at least decreasing over time? Yes, it is. This is a resample, I assume. Yeah. So it knows that this is getting less appealing, I think. But there will still have to be some fixes to this. And I'm going to have to think about how I think the quantile transform is going to mess up. It's going to mess up the cost penalty. I think that's likely. You need something that's at least linearly better, like a linear increase in cost, in score to justify the cost. And we'll look at it. Okay, I'm gonna go get food. It was exhausting. So I'm gonna get some food, check some emails, and then just chill out for the rest of the evening, most likely. Be back tomorrow. I think I've got some other stuff to work on other than this tomorrow. I really want to finish this though. This is gonna be so good when it's done. When I get this thing working properly, it's gonna be really good. But in the time being, thanks for tuning in. If you're interested in following all this work, everything you see here is free and open source. You can check out puffer.ai. Got all of our demos right here on Ocean. You can play all of these online as well, from very simple up to very complex. If you're looking to get into RL, looking for cutting edge RL improvements, got a whole bunch of stuff on our blog. We've also got a community Discord. You can start a repository to help us out. That really helps. And if you're looking for even more content, you can follow me on X, where I post a ton of RL stuff, including some articles you can't find anywhere else. So thank you, and